Assalamualaikum and good afternoon. Today we will talk about frequency response, and this is our group members for this assignment. First, in this assignment we will talk about the introduction of a transfer function. What we can see from here is pole and zero and transfer function. For the transfer function, is defined as the ratio of the Laplace transform of the output to the input with all initial conditions equal to 0. That's it, transfer function are defined only for linear time invariant system. For the factorization, a transfer function can be factored into following form. For the form that we can see from here is a standard form for zeros and pole. For this assignment, we have made a decision that we will choose the question number 4. For the problem that have been given, we will need to solve the problem about when h omega equal to 50 j omega divided by j omega plus 4 multiplied by j omega plus 10 the power of 2. To solve this problem and get the standard form so that we can plot it. First, we need to look at the denominator. What we can see from here is j omega plus 4. So we need to divide it by 4. For the j omega plus 10, the power of 2, we need to divide it by 10 also. Because the action that we have made in the denominator, so we need to do the same for the numerator also. After that, we will get the final form or the standard form that we can plot it on the block in the board plot. From the answer below, we know that if 50 divided by 400, we will get the amount that is very small. So first we need to change it into the whole number. By doing negative 20 log 400 divided by 50, we will get the whole number is negative 18 dB. The negative 18 dB will represent the constant gain that we need to plot it in the graph. For poles, as we can see, the poles we get is 4 and 10. For zeros is 1. As we know from the formula, zeros will equal to 20 logs j omega. And for poles, we know the formula is negative 20 logs 1 plus j omega over p of poles. For another one, we need to change the negative 20 log and change it to 40. This is because the n or the power of 2, meaning we need to multiply it by 2. And here is our phase calculation that we get from the transfer function problem. From this result, now we can plot it in the board plot. This is a magnitude board plot that has been done by me. For the first line is represent the zeros. From the second line, as we can see, is represent negative 40 log 1 plus j omega over 10. For the constant gain, we get negative 18 dB. So we need to line it above the point at negative 20. The third line for the poles represent the negative 20 log 1 plus j omega over 4. Lastly, for the magnitude board plot, we get the final form. The red color line is the final form that we get by combining all of them. And this is our phase board plot that we get from the result or the answer that we have solved before.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azamin bin Ali. I want to tell you about this board plot. For this board plot, firstly we have to solve this problem is we have to find the right form for the board plot to find the transfer function. The standard form for all transfer function is like this. But usually form we use for this dot plot is HW equal to K multiple with JW. Divide with 1 plus JW multiple 1 plus JW per P1. For the upper of this form we know as zeros and the under is for poles. Then we have to know the kernel frequency for this dot plot. The kernel frequency for this dot plot is we can see is 100 and 1000. For 100, the slope is 20 dB. Deck will changing to negative 20 dB deck. The slope will be in simple poles and we add in dot plot. The equation will be 1 plus JW per 100 in denominator. For 1000 kernel frequency, the slope is in 0 dB deck. Will changing and the slope will add. It will be simple pole axis. The equation will be 1 plus JW per 1000. For this dot plot, the form will be like this. From the form, we have to put the number kernel frequency at P1 and P2. Then we can factorize the under equation. After factorize, we can get the equation will be 1 per 100,000. The 100,000 we will bring to the upper equation. After that, find the value of k like this using 40 log k. Then from that we can find the right transfer function for this dot plot. Thank you.
Now we have solved the dot plot for the magnitude and phase. Now we will talk about discussion for this assignment. As we know, the dot plot is a graphical representation of the frequency response of a system, and it is also to analyze and design the linear time invariant system such as electrical circuits and control system. In a dot plot, also the magnitude and the phase of the system transfer function are plotted against the frequency. There is a lot of advantage of the dot plot, and one of the main advantage of the dot plot is it is ease of interpretation. The magnitude plot provides valuable information about the system's gain at different frequency. By observing the magnitude dot plot, it is possible to determine the system bandwidth, resonant frequencies, and stability. On the other hand, the phase plot provides information about the system's time delay and phase shift at a different frequency.
Conclusion from our assignment, the dot plot is powerful tool for analyzing and designing linear time invariant system. It provides valuable insight into the system frequency response, stability, and performance. The graphical representation of the transfer function, magnitude, and phase makes it easy interpret and compare different systems. Overall, the dot plot is an essential tool for engineers and scientists working with systems that exhibit frequency-dependent behavior.
That is all from us. Thanks again for your time, and Assalamualaikum.